Cinco, and the topic I chose is the networking fundamental, network type and topology, and network models. First on the list is networking fundamentals. Okay, so computer network is a set of computers connected together for the purpose of sharing resources. It can be connected using wireless means, using regular inference computing devices, including everything from mobile phones to a server. These devices are connected using physical wires such as fiber optics, but they can also be wireless. What are the components of the network? End devices and intermediary devices. Each end devices are computing devices at the edge of the network that can be sent or receive data. For instance, it may be a workstation, a laptop, desktop computer, scanner, tablet, or even a cell phone. Intermediary devices are devices that provide connectivity to the network, connect individual networks, and connect segments within the same network. Management of data as it goes to the network is also a role of the intermediary device. Hubs are network devices that connect multiple devices in a network and broadcast data to all connected devices. It operates at the physical layer and lacks intelligence to direct data to specific devices. Switches is a networking device that connects multiple devices in a network and intelligently forwards data to the specific device. It's intended for switches sends packet directly to devices rather than sending them to the network like a router does. A router is a networking device that connects multiple networks and directs data packets between them. It determines the best path of data, provides network segmentation, and supports VLAN, virtual LAN routing, and interconnectivity. A network card, also known as a network interface card or NIC, is a hardware component that enables a device to connect to the network. A network card enables a device to connect to a network, allowing communication by sending and receiving data over wired or wireless connections. A modem or modulator, the modulator converts digital signals from a device into analog signal for transmission over telephone or cable lines or vice versa, enabling internet connectivity. Next is the network types and topology. In this topic, I will tackle the three basic network types: client server and basic network topology. First, in the three network type is the LAN or local area network. A LAN connects device in a small area like office, home, enabling resources sharing and communication with high speed. It can be wired. It can be wireless. Second is MAN or metropolitan area network. It connects networks across a city or a large campus, providing high-speed communication and resource sharing over a broader area than a LAN. Wide area network connects network over large geographical areas such as cities or a country. It enables communication and data sharing globally, often using public networks like the internet. Next is the client-server model. The client-server model divides tasks between clients and servers. clients such as computers or applications makes requests for data or services, while server powerful systems handle and respond to those requests. This model is commonly used in web services, email systems, and database management, where multiple clients can access centralized resources and provided by the server. That is the network design or topology. Network topology refers to the physical or logical layout of a network device and connections. It defines how devices are engaged and how data flows between them. The first one is the bus topology. In bus topology, all devices are connected to a single central cable. Data travels along the cable in both directions. Second example is the ring topology, in which all devices are connected in a circular fashion and data travels in one direction around the ring. The third example is the star topology, in which all devices are connected in a central hub or switch. This is the most common setup in all modern networks. The last example is the hybrid topology. It is the combination of two or more topologies to meet specific network needs. The example below is an example of a topology in which it is a combination of a bus topology and ring topology. Uh, Network protocol and communication. Protocol is the rules that govern communications, in which it is made up of a group of related protocols that are necessary to communicate by electronic means. And network protocol describes processes such as the format or structure of the message, the process by which the networking device share information about pathways with other networks, how and when error. And system messages are passed between devices, and the setup and termination of data transfer sessions. Electrical and electronic engineers, IEE, and Internet Engineering Task Force, IETF, are organizations that define the standard we use in it today. Particularly, the network topologies IEEE standardizes communication protocols for hardware like Ethernet and Wi-Fi, ensuring device compatibility. IETF develops protocols like TCP/IP, HTTP, and DNS, enabling data transfer and communication across the internet. Next is the Common Network Protocol. Hypertext Transfer Protocol, or HTTP, is a common protocol that governs interactions between web servers and web clients. It also enables communication between web servers and servers to transfer data like web pages. It is stateless and typically used to support 84 requests and responses. Next is the TCP, or Transmission Control Protocol. It ensures reliable data transmission between devices by breaking down into packets and reassembling them at the destination. It provides error checking, retransmission, and ensures data is delivered in the correct order. Encapsulation and decapsulation. Encapsulation is the process of taking one data from one protocol and translating it into another protocol so that the data can continue across the network. It wraps the data with protocol-specific headers and trailers as it moves through the OSI model layer. This ensures proper formatting, addressing, and delivery across the network. On the other hand, decapsulation is the inverse of the encapsulation process. While the encapsulation process is wrapping the data, then Encapsulation process is the process of removing protocol headers and trailers from data as it moves from up the OSI layer. This retrieves the original data from the receiving application. Next topic is the network models. Protocol model and reference model. Protocol model provides a model that is closely equivalent to the structure of a certain model. It outlines how network protocols operate and interact to ensure data communication. Reference model provides common reference for maintaining consistency within all types of network protocols and services. As it is a conceptual framework that standardizes the functions of a communication system to ensure interoperability. Next is the OSI model. OSI stands for Open System Interconnect. It is the framework that defines how data is transmitted across the network. It breaks communication into 7 layers, each with specific tasks ensuring standardization and interoperability between different systems and devices. TCP/IP model is a 4-layer framework that standardizes internet communication. It includes application, transport, internet, and network access layers to ensure reliable data transfer and connectivity. The OSI model provides a standardized reference for understanding how network protocols and technologies operate, making it a fundamental tool in networking and communication. OSI model consists of 7 layers: the physical data link, network link, transport session, presentation, and application layer. Each layer has a specific task in the network. The first one is the physical layer. It is responsible for the transmission of raw data over physical media like cable fibers or wireless signals. It defines hardware standards, signaling, and data rate. The data link layer is the second layer of the OSI model. It manages reliable data transfer between devices by organizing data into frames, handling error detection, correction, and flow control. It also manages MAC addressing for device identification. The network layer is the third layer of the OSI model. It handles routing, IP addressing, and forwarding data packets between devices across different networks. It ensures data reaches the correct destination. The transport layer is the fourth layer of the OSI model. It ensures reliable data delivery between devices, manages flow control, error detection, and retransmission using protocols like TCP and UDP. The session layer is the fifth layer of the OSI, and it manages the control and controls the dialogue between two devices, establishing, maintaining, and terminating communication sessions. It ensures data is properly synchronized and handles issues like data exchange, initiating, and termination. The presentation layer is the sixth layer of the OSI model. It ensures data is properly formatted, encrypted, and compressed for the application layer, enabling compatibility between different systems. The application layer is the seventh layer of the OSI model. It provides network service directly to end users and applications, such as web browsing, email, and file transfer. It enables communication between software application and the network. The OSI model, or Open System Interconnection, is one of the standards developed by ISO, or International Organization for Standardization. It is a conceptual framework that defines how different networking protocols and devices should interact. TCP/IP model is used over the internet and this layer consists of 4 layers: the network access, internet transport, and application. TCP/IP, or Transmission Control Protocol Interprotocol, is a set of protocols that governs how data is transmitted over the internet and other networks. It ensures reliable end-to-end communication by breaking data into packets and addressing and routing the packets. The network access layer is the lowest layer of the TCP/IP model. It handles the physical transmission of data over the network hardware, including protocols like Ethernet and Wi-Fi. This layer manages data how it's framed, addressed, and transmitted over the physical medium. The Internet layer is the second layer of the TCP/IP model. It is responsible for routing data packets across different networks using IP or Internet protocol. It ensures that data is delivered to the correct destination by assigning IP addressing and determining the best path for transmission. The transport layer is the third layer of the TCP/IP model. It ensures reliable data transfer between devices, handling error detection, correction, and flow control. It uses protocol like TCP and reliable communication, and UDP or user datagram protocol for faster connectionless transmission. The application layer is the top layer of the TCP/IP model. It provides a network service directly to end users and applications, enabling communication through protocols like HTTP, FTP, SMTP, and DNS. It supports functions such as web browsing, file transfer, email communication, and domain name resolution. The OSI model and TCP/IP model differ in the number of functions of the layers. In the OSI model, there are several layers starting from physical, which deals with the transmission media, up to the application layer, which manages the end user application like HTTP or FTP. The transport layer in OSI handles reliable communication using protocols like TCP and UDP, while the network layer is responsible for addressing and routing data such as IP. The session and presentation layer in OSI are distinct, handling session and management, and data formatting, encryption, and compression. In contrast to the TCP/IP model, simplifies these functions into four layers: network access, internet transport, and application. The network access layer combines the OSI's data link and physical layer, while the transport layer in TCP/IP performs the same function as OSI's transport layer. The internet layer in TCP/IP corresponds to OSI's network layer, handling routing and addressing with IP. Finally, TCP/IP merges OSI's session and presentation layer into the application, which manages both users' application and the related session and data handling task.